Solve problem 1.1 charged balls. Problem two identical charged balls hang from the ceiling by insulated ropes of equal length L equals 1.50 meter. A charge Q equals 25 microcoulomb is applied to each ball. Then the two balls hang at rest and each supporting rope has an angle of 25 degrees with respect to the vertical. What is the mass of each ball? Okay, so we have a diagram here on the right side. So you have two balls hanging from a ceiling, right? This is the ceiling and these are the two balls. And these two balls have same exact charge on it plus 25 microcoulomb. That means both of these balls are positively charged. And the length of this rope is also given. So let's write down the givens first. Givens. Length of the rope is given 1.50 meter. That means this length is 1.50 meter. This length is also 1.50 meter. Next one, charge is also given. Both balls have equal charge. Let's call the first ball A, this ball A and this ball B. So QA equals QB equals 25 microcoulomb, right? So just call it Q, 25 microcoulomb. No need to put A and B here because they have same charge. So let's call it Q. Yeah. Okay. So what else is given? Two balls hang at rest and each supporting rope has an angle 25 degrees. That means if you draw a normal here, this angle theta is 25 degrees. That is also given. Yeah. So we need to find the mass of each ball. So you need to find the mass of this one and this one. Both of them will be same. So we are going to find the mass of this particular ball. Yeah. We have free body diagram of this ball here. So it has all the forces acting on this ball. Ball has a mass, so it will be attracted by the gravitational force. Gravitational force is vertically downwards. You can see the direction of gravitational force here. It's represented using purple arrow, and there is tension here. Ball is hanging using a rope. The force acting through the rope is tension. So there is tension acting through the rope. So this is the direction of tension force. And these two balls are positively charged. So there will be repulsive force between them, repulsive electrostatic force between them. So the force of repulsion is in this direction, right? This ball will try to push it away from it. So the direction of repulsive force is in this direction. Yeah. So yeah, this is the direction of electrostatic force. Ball has no net force acting on it. It's not moving, it's staying there, it's at rest. So net force is 0. Now we are going to find, so think about it. Fg is on minus y-axis, Fe is on minus x-axis. Tension is on in between plus x and plus y, right? So we need to find the components of tension. We are going to treat x and y axis separately. So we need all the forces on either x or y axis. But tension here, tension is not on x or y, it's between x, y. So we need to find the components of tension, x component and y component here. So I will draw the x component and y components of tension. So x component will be along the x axis in this direction. This will be the x component of tension, and y component will be vertically upwards along the y-axis. So this is the y component of tension, and y, okay, there is a shortcut to find the components. Theta is touching ty, right? So ty equals t cosine theta, and tx equals t sine theta. This is the shortcut we use. This is the shortcut we use to find the x and y components. You can see here theta is touching y component, so ty is t cos theta, and tx is not touching the theta here, so tx is t sin theta. So these are the two components of tension. Let's call it 1 and 2, equation number 1, equation number 2. Now I'm going to add all the forces on x-axis. So on x-axis, now focus on x-axis. How many forces are there? 2, right? Tx is going towards right and Fe is going towards left. Okay, net force is 0. So how do you write the equation? Net force on x-axis, equals, how many forces are there? 2 forces, F1 plus F2. What is net force here? There is no net force because there is no movement, acceleration is 0, so net force is 0. What is F1? F1 Tx plus Tx, it's going to the right, so take it as positive. And what about the second force? It's minus Fe because it's going to the left, so minus Fe. So if you rearrange this equation, you will get minus Fe going to the left plus Fe. So Tx equals Fe. And what is Tx? T sin theta. So T sin theta equals Fe. I'm going to call it equation number 3. Yeah. Okay. Next, we're going to do the same thing for y-axis. On y-axis, how many forces are there? Again 2, right? Ty going upwards, Fg going downwards. So how do you write the equation? F net on y equals F1 plus F2. There are 2 forces. Again, there is no net force on y-axis because there is no acceleration on y-axis. It's not moving. So 0 equals, what is F1? It's Ty plus Ty because it's going upwards, so take it as positive, plus Ty minus Fg. Yeah. So if you rearrange it, you will get Fg equals, same thing, yeah. Ty equals Fg, same thing, I want to write just like this, yeah. Ty equals Fg, and what is Ty? T cos theta. So T cos theta equals Fg. Let's call this equation number 4. Okay, so these are the 2 equations for x-axis and y-axis. Equation number 3, T sin theta equals Fe, and equation number 4, T cos theta equals Fg. In these equations there are tension, right? There's tension here and there's tension here, but tension is not given in the question, so we cannot solve the problem. We cannot solve an equation if tension is in that equation, right? So we need to eliminate tension. How can we eliminate tension? Think about it. We have 2 equations, right? T times sin theta equals Fe, T times cos theta equals Fg. So if you divide these 2 equations, you can get rid of T. You can cancel out T. I'll show you that. I'm going to divide 3 with 4. Equation number 3 divided by equation number 4. Okay, what is equation number 3? Equation number 3 is T sin theta equals Fe. So T sin theta equals Fe over, what is the second equation? Left hand side, T cos theta, right? Right hand side, Fg. So T and T can be cancelled out. T and T can be eliminated. And what is sine theta by cos theta? It's tan theta, right? Tan theta equals Fe over Fg. Yeah. So we have another equation here. Let's call it equation number 5. Yeah, in equation number 5, what is Fg? Fg is the gravitational force. We know the equation of gravitational force, mg, right? Let's call it equation number 6. But what about Fe? Fe, it's not given in the question. So we need to find Fe, right? So that's our next objective, to find electrostatic force. Yeah, we have Coulomb's law. By Coulomb's law, electrostatic force equals K Q1 Q2 over R square, right? In our question, both the balls have same charge. So instead of Q1 and Q2, we can write Q and Q because they have same charge. So Fe equals K Q Q over R square. So Fe equals K Q square over R square, right? Yeah. So that's the equation for Fe. Now there is another problem. What is R? R is the distance between these two balls, or we can call it D. Yeah, okay, let's call it D. Yeah, okay. D square, right? Yeah, D square. Q is given, K is a constant 9 into 10 to the power of 9, but D is unknown. We need to find D. So that's our next objective. We can call this equation number 7. So our next objective is to find a distance between two balls, D. I'll draw a picture here. So this is ball number 1, this is ball number 2, and they are separated by a distance D. Okay, our objective is to find this distance. Yeah. So what I'm going to do is I'm going to divide this into half, like this. Okay. Yeah. So this distance will be D over 2, right? What about this distance? It's L, length of the rope. That is L, right? And this is 90 degree. So L is the hypotenuse, and this theta is given in the question, 23 degrees something. Yeah, 25 degrees. Yes, this theta is 25 degrees. Yeah. So from the picture, D by 2 is the opposite side, and L is the hypotenuse. So what is opposite side over hypotenuse? Which trigonometric function is opposite side by hypotenuse? It's sine theta, right? Yeah. So sine theta equals opposite side by hypotenuse, or sine theta equals, what is opposite side? This is theta, so opposite side of theta is D over 2. So D by 2 over, what is L? What is hypotenuse? It's L. L. So sine theta, we can solve it. Sine theta equals D by 2L. If you cross multiply, you will get D equals 2L sine theta. That is the equation for D. Let's call it equation number 8. So we found D, or we calculated D to put here in equation number 7, right? Because in equation number 7, we didn't have D. That's why we found D. Okay, now we got D, so we are going to substitute it back to equation number 7. So substituting equation number 8 in equation number 7. Yeah, so Fe equals KQ square over, what is D? D is 2L sine theta, right? 2L sine theta but in the equation it's d square, so you have to take the square as well. So Fe equals kq square over applying square for 2 square is 4, L square is L square, then sine theta or sine square theta, or I can write it like this, sine square theta. Okay, that is Fe. Let's call this equation number 9. So we got Fe and Fg. So Fg is mg, equation number 6. Fe is kq square over 4L square sine square theta. Now we can substitute equation number 6 and equation number 9 in equation number 5, right? Tan theta equals Fe over Fg. I'll write that equation here. So equation number 5 is tan theta equals Fe over Fg. So tan theta equals, what is Fe? Fe, equation number 9. So I'm going to substitute equation number 9 and equation number 6 in equation number 5. Yeah. Okay. So tan theta equals, okay, let's go back to equation number 5. Tan theta equals, what is Fe? Kq square over 4L square sine square theta. I'll use a different color. So this is Fe, right? So Fe is in red color and Fg is in green color. Okay, what is Fe? Kq square over 4L square sine square theta, or sine theta the whole square. Yeah. Over, what is Fg? Fg is equation number 6. Fg is mg. So Fg is mg. Okay. Now, if you have to solve a by b divided by c, how do you solve it? This is a by b, this is c, or you can write it like c by 1, right? Okay, so you are dividing it, so you have to multiply it, to find the inverse and multiply it. So a by b times, what is the inverse of c by 1? 1 by c. So it will be a times 1 is a over bc, right? So similarly, we are going to add mg to the denominator. So yeah, so tan theta sorry about that. Yeah, tan theta equals kq square over 4L square sine square theta times mg will be added to the denominator, so mg. But we don't need to find tan theta, we need to find m. So cross multiply it, so you can take m to the left and tan theta to the right, right denominator. So m is going to the top of left hand side. So m equals kq square over 4L square. There is g as well. Yeah, there is g here. Yeah, 4. Okay, let's write it like, yeah. So m is going to the left and tan theta is coming down. So kq square is on the top. 4 g L square, we have sine theta the whole square, and this tan theta is in the denominator, right? It's here, tan theta. Yeah, that's your final equation, kq square over 4gl square sine square theta tan theta equals m. Now let's substitute all the values. What is k? 9 into 10 to the power of 9. Q is 25, check, 25 microcoulomb, 25, what is micro? 10 to the power minus 6 whole square over 4 into g is 9.8 times length is 1.5 square times sine theta is 25 degrees. Make sure theta is in degrees in your calculator, not in radians, times tan 25. So if you solve it, you will get 0.76 kilograms. That is the mass of ball A and ball B. Thank you guys.